So there are a few ways to do this problem, but I'm just going to show you the way I found the easiest. So the first thing you're going to do is just note that the outer radius of this part, which is also the inner radius of this part, is going to be 6 centimeters. So I would recommend the first thing doing is just making sure the tire is right. So I'm just going to start by doing that. And of course make sure that you are in centimeters. So radius is 6. And now for the outer radius, which is 10. And from there you're going to extrude 4 centimeters. Now from here you can change the color. You obviously don't need to do this, but I find it easier later on when you're putting two parts together. So for the inner part, I'm just going to have it made already because it would take too long to do this, obviously. You don't need to do this extensive, but I just felt like going for awesomeness points, so. Now we're just going to go into an assembly. Oops. And insert both parts. Obviously, when you're making the inner part, just make sure that the outer radius is 6 centimeters also, otherwise they won't mate properly. And now we're just going to mate these together. Alright, now before you go into the motion analysis, there is one important thing you need to do. That is just the masses. So in this problem it is only focusing on the mass of the tire itself, so the inner part is irrelevant, but you'll see why it is actually relevant for the simulation later. So first we're going to say that the mass of the tire, if you go to evaluate and mass properties and override, we're going to say the mass of the tire is 30 kilograms or 30,000 grams in this case. And all set. And now this part's important. So this is actually going to be 0 because, like I said, this part is not exactly relevant to the calculations by hand. But this isn't actually 0 though. This is just 10 to the about -6 grams, because if you actually put in 0, it just won't let you do it because it would be as if it wasn't even in the simulation. So now we're just going to go to assembly and motion study. Now make sure you have your add-ins. Motion, good. Motion analysis. Now what we're going to do is add a torque, which is just a moment in this case. So in the problem, it says we are given this equation of moment, which is this. So all you're going to do is scroll down and go to expression, which will allow you to type in this function. And just make sure you get all of your mathematical functions correct, and they're all listed down here if you need to check. And check mark up here. Alright, so when you see this at first, you might not think that it's the right graph, but actually, if you see here, it goes all the way up to 30. So all you need to do to confirm that it's correct is go to maximum value of x to 30 and fit to all graphs. and you can see that they're clearly the same. So from here, press OK, and we are going to apply it to this face right here. And this motion is representing where it will move, and this is obviously how the tire will move, so that is the right way. And check. So when running the simulation, probably the best way to do this is to solve backwards. So essentially you're using the value you calculated to try to find the angular velocity, which is given. So best way to do this is just to zoom in and find the calculated value, which is 3.85 seconds. Oops. So you need to pull this back because this will stop the simulation wherever you have this. For 3.85 seconds. So this is good. And now, before you actually run this, another important thing is to just make sure that the inner is fixed, which is just the gray part, and then the tire is not fixed because the tire is the only thing rotating. And this is the important part of making it two parts in this case, because it's acting as if this is pretty much just stabilizing the tire, so the tire is moving freely. But obviously if you were to have not this here, then it would just, you can't fix it and have it rotate at the same time, so it would just fall or just do nothing. So yep, now we are just going to run it. And we're going to plot for angular velocity. And it's going to be in the z component because it's rotating about the z-axis in this case. Didn't seem to want to work. Alright, let's try this one. It's the same thing. Okay, so everything's the same here. We're just gonna plot for angular velocity, not the z component. Select this face, and need to roll back time again. So now, if you go all the way to the end, you'll see so 57,234 degrees, and if you just multiply that by 180 divided by pi to convert it, and you'll find that it's 1,000 radians, because right now it's in degrees, but if you just convert it using that, you'll just find it in radians, and that is 1,000 radians. So that's the same thing as problem. So working our way backwards, we found that this is actually the right time.